Hello, this is the second video in a set which we're using to help reinforce the idea of class hierarchies and abstract classes. So in the last video we talked about how I was setting up this specific example. And again, I stressed the point that the key is not to get caught up in how each of these methods is actually executed. Many of them just simply print out a line to the screen, but to understand how the three classes relate and where I put methods in the program. Okay, so now that we've talked about the structure, let's actually now look at the program. So you'll see at the start that I have my animal class, and again we have a string called name, integer called age, and an integer for strength. And we have two constructors. We have a structure that takes a string, an integer, and two integers. And we have a constructor which takes just a string, setting age and strength with some default values. We have our sleep method. And remember, like we said, is since the sheep and lion both have common sleep elements or common sleep behaviors, that is, we increase the strength by 1, we're going to need a sleep method here with some code in it. We have an eat method, and again, since the sheep and lions have common eat behaviors, that is, their strength increases by 1, we need the eat method here with some code in it. We have the protect method, and again, this was a funny one because we have no code in it, but we've left it here. And we'll look shortly at why we, at this point, have to keep this here. But there's no common code between the lion and the sheep, so what we do is we actually rewrite this method in both of the subclasses, and then behaves accordingly. And then we have our accessor methods, our mutator methods, and our toString method. So let's take a look now at the lion. So again, like we said, the lion has no fields, and we have two constructors for the lion. Really make sure you understand this idea of super in the constructor. It's a really important concept to grab onto, and we'll touch on it as we talk about this more. So we've written a method in the lion called eat. So this version of eat here is the overridden eat method, and that's because it has no parameters, just like the eat method in the super class. We see that we've also overloaded the eat method. And an interesting you'll note here is that I've made the eat method that takes a Boolean parameter private. And that's because in my design specification, the only place that this eat method will be called is from this eat method inside the lion class. And we'll talk in more detail about that shortly. We have the protect method for the lion. It simply prints out lion protecting, however the lion might do that. And then we have no accessors or mutators. Also, we have no toString because the lion has no unique fields to print out. Now let's look at sheep. So the sheep has a private herd size. We have a private, which represents wool quality. We have a private, which represents wool length. And we have a private, which represents whether or not the wool is ready. So these are all private fields. We've encapsulated it, and it's important you always do this. You might have noticed here at animal that I did that as well. Really important that you include the private modifier. And again, we have some sheep constructors, calling the super constructor. And a point that I'd like to stress here, and we'll talk about this more in class, is that if in most of our examples we've had a single superclass, removing considerations of the object class. So we often only think of the super constructor call going one class set of constructors above. But it's important to know that if you had, say, a hierarchy where there's a superclass and then another superclass above it, the super call would actually check first the immediate superclass and then the superclass of the superclass as well for that constructor. So we randomly generate the wool quality, the wool length, and whether or not the wool is ready. Here's our other constructor, third constructor, a fourth constructor. I've made a lot of constructors for this guy. Take a second, look through them, see if you understand them. So we have a shear sheep process. In the shear sheep process, there's some code in here. We have a sleep. Remember, like we said, the sheep can only sleep if there's no predators in the vicinity. So we have some logic here to simulate whether or not there's a predator in the nearby countryside. Again, to reinforce the point, lions can sleep, however, whenever they want. So there's no unique code for the sleep method for the lion, so there's no sleep method implemented in the lion class. We have the protect method. So again, remember we said that both the lion and the sheep protect themselves in a unique manner with no common elements. So we have to have a method in each of those classes. And again, we've implemented a protect method in the animal class, but there's nothing in it. And we'll see why that is shortly. Then of course, sheep has accessor methods, set methods, or mutator methods. And we have a toString method because we want to access the unique fields in the sheep class. So currently, the way this is set up, we're able to set up an animal runner. We can make a line, so line1 equals new lion. We can call the constructor accordingly. We can make a sheep. We can also make an animal, or we could make this situation where we could make the type is an animal, but we construct an actual lion. And this has raised a lot of questions in class about what the usefulness of this is. And at our level, this is really useful for us when we're using array lists. And we're not going to see that as much in the next couple videos, but you'll see in Animal Runner 2 a little later an example of where this comes in useful. So I'm going to pause this here, and in the next video we'll take a look at the Animal Runner and follow through the logic here.